We've decided to base our model on The Tale of Peter Rabbit by Beatrix Potter. Here's a little bit of the story that we found most influential.
First he ate some lettuces and some French beans, and then he ate some radishes.
And then, feeling rather sick, he went to look for some parsley.
But round the end of the cucumber frame, who should he meet but Mr. McGregor?
In this part of the story, we have created our model. Here you can see the front view of our model. On the side, you can also see this for Mr. McGregor moving, the cam system. On the back, we have also added some pictures from different novels of Beatrix Potter. So this could be a lesson extension. And then on the other side, we also have part of the pneumatic system, which pushes Peter along.
So this is the top of our model where all the action happens. Basically the way it is in the book. So Peter's running past the gate through a series of vegetables in a garden towards carrots, and Mr. McGregor is at the end. So within the model we have a couple items such as this gate, this sign and this little lattice, which are all made of pop sticks. These little pebbles are also made from salt dough, as are the cabbages and the carrots. We painted all three of these items, and we created Peter Rabbit's jacket sitting on a scarecrow just like it does in the book. So this also added a bit of textiles within our model. We created a series of mind maps, and we chucked around a couple book options such as Wizard of Oz, Peter Pan and a couple others. And basically kept running around in circles until we found Peter Rabbit, and then as soon as that came about we started creating written boards,
Concept maps
and things like
to get
that.
our ideas down on paper.
Yeah, and we found that really helped to in order to find out what materials we wanted to use and also what systems we wanted to use. Reflecting back on what we did in class and looking at what other students have done in their models helped us decide what would be most beneficial. Is pneumatics, and it's used to move Peter across, and he's actually running towards the carrots, which happens in the story. So if you push that syringe in, he moves across the model. So pneumatics is made by air movement, and you can see on the inside of our model we've got two syringes and a plastic tube that connects them, which the air is held in one of the chambers until it's pushed into the next chamber.
So you turn the cog this way and it makes Mr. McGregor move up and down as if he's looking for Peter. So on the inside, it's made up here of a series of shafts, slides and discs.
Adds an extra teaching tool within the model. So basically the way it works is there's a series of true or false questions inside the bubbles, and when one of them is clicked, the light switch turns on. There's a series of conductors within the model. These are the split pins which appear next to the questions, and then the wires which appear behind. These are all created in a way that when the correct answers are touched by these little wire remotes, the full circuit is made and the light will turn on.
The source of the electrical energy is a battery here, placed here, which is then attached to the bulb.
We attempted to make a wheel out of laminating sheet, and when we put that on our model we really just found that it wasn't heavy enough and gravity didn't pull it down against the cam, and it didn't turn and create a smooth movement that we wanted. So eventually we got one of these red wheels and put that on, slightly altering the way it hit the cam, and we now find that that creates a much smoother movement, and it can go back and forth both ways, which is really good when students are using it.
We decided to use textiles. We tried to sew together our own little Peter. However, it was really difficult to make, and it was too big for the scale of our model. So we also thought that it would be beneficial if Peter was smaller, so that he would look like he travelled more when we use a pneumatic system. So instead, we cut out Peter and laminated him. So it was important when collaborating with each other that we used our communication skills. This was really important to get across our ideas to one another. We were really lucky. We got to spend the whole day together. We went shopping together, picked out all the same materials. We also spent the whole day dividing up little parts of it, but we all managed to do the same amount. We think it will be a really useful teaching tool for things like health, English, and definitely design technology.
One thing that we are reflecting on is the fact that our model is quite big. Know from experience on prac, classrooms are busy and they don't have a lot of extra space. Overall, we're definitely really happy and proud of what we've achieved and look forward to using in our teaching. So